Hello everyone, my name is Daniel Gerd Nielsen. I'm the product manager of the Treble SDK, and you've tuned in to a longer in-depth video of explaining IR collections basically and what they enable and what they do in the SDK. And I'm quite excited to take you through different workflows to sort of unpack the feature a bit more than we did in the webinar, and hopefully you find this interesting, and you can go through the notebook as well in your own time. We made this feature first of all because a lot of our users would like an easier way of collaborating on datasets. Oftentimes there will be one department doing the simulations and maybe some filtering, processing, device rendering, and then it would be handed over to a different department, which might be doing the downstream task training and evaluation and so on. And this sort of discontinuity caused some, you could say, friction or issues with handing over this data. So this feature solves that by making it very easy and fast to share data in kind of a commonly known format. It also makes it a lot easier to organize your data. So perhaps you could say you're simulating over time, you're building up a lot of simulations, but it's quite scattered. And it can be difficult to find and sort of collect in one, especially if you want to do bulk processing and bulk data handling, bulk metadata creation. You do not want to repeat that process 5, 10, or 20 times. You want to get it over with and then sort of have all your data in one data structure. And that's kind of also what we're addressing with the collections feature. And then you want to be able to use, you can say, all the spatial information, all the acoustic information that's present in these simulations that you've made. You want to be sure that they propagate, you can say, into this data structure. So you can append metadata to it related to spatial information, acoustic information, and so on, so that can be used and consumed later on in the process when you make audio scenes and so on. The feature also enables bulk processing. I think that's also important to mention. So for example, if you want to do device renders in bulk, you want to do some certain filter types and so on in bulk, you can also do that with the IR collections feature. So I'm going to walk through a few examples with you today to sort of give you a bit more in-depth feeling for what this feature can do. So first of all, I want to start from building an IR collection from a simulation collection, which is, you could say, based off simulations and projects and so on. So I want to take you through that workflow to see how you get to the IR collection stage. Then I also want to start from a completely different point where we just access a pre-run dataset by Treble, and we'll take on to it in Treble10, and that's freely available for everyone with an SDK subscription. And you can start, you can say, with this very high quality and curated dataset to then set up, you could say, some processing, append some metadata, and then you can use that to generate an audio scene. So that is for everyone that you could say maybe doesn't have the bandwidth or the capabilities to run a lot of simulations. You can basically just fetch pre-made datasets from the SDK, which you can then use for your work, basically. And Treble10 is one example, but we have thousands and thousands of IRs in different packages from different environments that you can browse and look at. And then finally, I'll show and go in depth with how we work with an IR collection. So just to recap here, the IR collections builds on top of very well-known industry formats and methods. So it builds on Parquet files, which is very memory efficient. And we're pairing that with the Polars data frame, which works in parallel and memory efficient and is very fast to query. You will see here that I work with hundreds and thousands of IRs, and I can do my access and my filtering and so on in a matter of seconds. The nice thing here is that we are sort of connecting these well-known structures with the underlying model information and simulation information that is present in the SDK, which makes it very, very easy for you to append, let's say, for example, spatial metadata. So you want to know your device location in space. You want to know how close is it to a wall. Is there a line of sight between my device, my receiver, to the source, and so on. All these things are known because you have the underlying model, and it's very easy for you to then append this information into this data structure. Similarly, you can append acoustic metadata. That would, for example, be the reverb time of the space of where the IR was simulated in, the clarity index, early decay time, and these kind of parameters can be very easily appended to the data frame. And if you want to do your own custom calculations, you can also do that. And this plugs seamlessly into machine learning workflows in the sense that we have quite efficient data loaders, which enable you to lazy load the IRs into your training machine or your scene generation pipeline. That's on the one hand. And on the other hand, we also enable audio scene generation, where you basically plug in this IR collection, and then there's a new feature in the SDK called audio scene generation that takes in a collection and can generate very rich and advanced acoustic scenes with speech and noise from these IR collections. So let's get started here. So first of all, I'm just logging in to the SDK, and then the next thing I want to do is I want to fetch the simulations that we want to include in our simulation. So here I'm actually working with the dataset that I also showed in the webinar. So we simulated 1 million impulse responses in a project, and what I'm doing here is I'm then fetching those. So I'm looking for, you can say, simulations in this project that have the status completed, and then I want to get you could say report on how many that actually is. And we see here it's a bit more than 1 million room impulse responses across 1,000 simulations. Here I've commented out, but it's also just to show you that you can say, if you want to combine multiple projects or multiple simulations from different projects into a simulation or into a collection, you can do that, and the code for that is basically here. That will also be included in this notebook that's shipped together with this recording. So now we have fetched around 1,000 simulations, and I want to create a simulation collection from that, because I need the simulation collection to create a IR collection of the impulse responses. So we see here we have around 1,000 simulations, and I can see some metadata already here about the simulation, basically. I can then, if I want, add new information on a simulation level, basically. So that could be a train and test split, and here I'm just kind of doing it randomized. So I'm adding either A, B, and C to the collection, to the data frame. So we can just kind of see here that now if I scroll all the way to the right, we have now a new column, which basically are letters either A, B, or C. Okay. Then I can, for example, make new collections based on these letters. So I can make a collection of A and a collection of B. Now I can then, if I plot my collection A data frame, you can see I have fewer simulations, but also, like, if I now look at the set column, they all have the value A. So perhaps I'm happy with this simulation collection, and I want to create an IR collection from that. I would then, you can say, use this get IR collection from the simulation collection, and here I pass the argument inherit columns. So I want to inherit the set column in the IR collection, so that we have this information that we just created with it. So now I have created the IR collection from my simulation collection. I use the entire simulation collection, which means I create the IR collections from the 1,000 simulations. So we expect to have around 1 million IRs here, which we do. And we see that the information here is now much more rich because we have each individual IR in the simulations, right? So we have information about if it's a spatial IR, what kind of source it is, the location of the source, if it's a directive omni source, boundary velocity source, and so on. Same for the receivers. We have information about if the location, the ambisonics order, the distance between the source and the receiver is always pre-computed. And then we also see our custom column here to the right. The set is also present. Great. Then maybe I want a more simple structure for my IR collection. I can remove some columns. So let's say that we have some required columns that are always needed. which you can print out here with the required columns command. And then we have the current columns in the IR collection. So actually I know I'm not interested in the ambisonics order or the IR type, so I can easily remove those. And then if I want, I can save my my impulse response collection, which I'm doing here, in just below a second. And then to show you here, I can very easily load it again. So that was a bit about how you create an IR collection from a simulation collection. So we're now moving into looking at these pre-run or pre-made datasets that you can access through the SDK. And I would like to take Onset into this free collection that we made together with Hugging Face called Treble10. It has around 3,000 IRs in it, and I will show you how to, first of all, fetch this dataset so you can use it if you're interested in that. But also to show you kind of different techniques and workflows with the IR collection so that you hopefully can use these in your own work, either with your own data or these pre-made datasets. So I'm just starting here. We have some information about how you can use this dataset feature. So you can browse available datasets to you. You can fetch datasets. You can get IR collections, so collections you or your colleagues have saved. They are available to you in the SDK. You can also save IR collections into this dataset structure. So I can start with displaying what datasets are available to me right now. And we see, for example, the Treble10 here, and the cost is free, so I can just get that with a few lines of code. I'll show you that. And then furthermore, we have lots of different datasets. For example, this Treble small, medium, and large dataset. That if you look at the whole thing, it has 30,000 IRs in them of very high quality. And those were also the ones that all our research results in the webinar was based on, where we saw a 30% reduction in word error rate, and also a 0.2 increase in PESC for a quite difficult monaural case. So encourage you to check these results out as well. So I want to get the Treble10 dataset, kind of straightforward. I just purchase it, and then I get no prompts because it's free, so it's just get into my account immediately. And if I plot this collection, I see these 3,000 IRs here. And we can plot it more visually. So here it's a nice little plot widget we made, so to visualize the data. So for example, maybe I'm interested in plotting something slightly meaningful here, and then show the source receiver distance for the whole dataset, and then we can see that most of the sources are, I could say, about 2 meters more or less between them. But we also have examples where there's quite a nice distance in the source receiver distance. It's very straightforward for me to then just plot an example here, just for you to get sort of an idea of what did the underlying simulation actually look like. I can run this command and plot the room plus the receiver configuration plus the source configuration, and you can also see what kind of materials were assigned to the walls and so on. So the way these are made is that we have this grid of receivers which were made with a built-in Treble command, so it's very straightforward to place grids and receivers or random source locations with certain rules in the SDK. There are 5 sources and a lot of receivers in this room, and you can see the different layers here and so on. All this information is basically available to you, and then you can also get more information about the placement of the sources and the receivers. I then want to, you can say, add more metadata to this. So as you saw before, the data frame contains some basic information, mostly related to types of sources, receivers, and the location in space. But it's kind of straightforward for me to fetch the results, the underlying results, and then add that to the data frame. With this command, I can see what acoustic parameters are available for me to add in. It's quite a few. And I choose to then to add these 4 parameters, T20, T30, and T50. Working on these 3,000 IRs, it takes me around 3 seconds to add this information. Actually, I also want a bit more spatial information. We have some built-in commands here that are quite helpful, and you can also, of course, also do your own calculations and add. But we have some built-in functions that might cover some of your needs. One of them being if there's line of sight between the source and receiver. So I can compute this for the 3,000 IRs here. It takes me a couple of seconds to basically I loop through all the models and all the receiver and source locations behind the scenes and compute this. but still we managed to do it in just 6 seconds. And then finally, I also do a wildcard search on the walls. I just use LL here with wildcards. What I'm doing here is I'm computing the distance from all my receiver locations in all of the 10 models to the nearest wall, basically. So I have that information as well in my dataset. Okay, so in a little bit less than a minute, we managed to loop through all the layers and all the receiver locations, and then we added information about the distance to these layers. Finally, I want to categorize my sources. So when I create my audio scenes in the scene generator tool, we, for example, work on different labels and tag structures. So before sort of going into the scene generation, I can add metadata if you could say a source is, in this case, an HVAC, a talker, or a dog. It could also be, if it's a noise source, if it's a keyboard clacking on a table, and all these kind of things. You can very easily add these labels. So I'm just going to go through the data frame here and add this information. And now let's try to plot, because now we've appended quite a bit of metadata that we can use for our scene generation. And we see that's appended when we go to the right here. So for example, we see the T20, T30, C50, and early decay time has been added here. We see, you could say, a Boolean variable related to line of sight. We see the distance to the nearest wall, and we also see these source tags here, basically. Okay. I actually then remember that I don't need the T30 because I already have the T20, so I can just easily delete this column. Takes 0 seconds basically, and then if I look at now my acoustic parameters as part of this data frame, this collection, it's only T20, C50, and the early decay time. And now I can again visualize the data frame, the data structure here, and now I have much more information available to me. So I can, for example, plot the C50 here, and I can overlay this with different kinds of information. So for example, maybe I'm interested in knowing line of sight. We see most of them has line of sight, but there's a few that does not. We can also see our new source tags, maybe. How many are talkers, how many are HVACs. I mean, it's also interesting for you if you're doing, you can say, speech and noise. You want to be sure that there's a good distribution between those. This could be one way of checking that, right? And there's also violent plots and so on that you can use and visualize the data, communicate with your different teams that are using this data, leadership, other stakeholders, and so on. This should be very straightforward. That's at least the intention. Then we're sort of now going into a more granular control of the underlying data. Maybe we have very specific wishes. So for example, I can create here a subset data frame which only contains source receiver distances that are lower than 2 meters. I can say that I only want data from living room environments. I believe there are 2 of those. Or I can filter, you can say on the IR length, say, okay, I only want IRs that are longer or shorter than 0.5 seconds. I can also create distributions. So for example, I can create a Gaussian distribution with T20. I can create a uniform distribution with C50. So let's go ahead and do that. Still very fast, of course. And then I can plot the C50 distribution here. So now I'm only looking at 100 IRs, right? Because that's what I asked for here with the number of samples. I'm just gonna pull out this. Here we go. So more or less even distribution here between 2 and 20, which is what we asked for. And now I'm satisfied. I want to save just maybe the enriched dataset of where I have appended all this metadata. So I select my IR collection and I give it a name and I give it a description, and then I can easily save this to sort of this global collection of this tsdk.datasets I started by introducing. This dataset now lives there and can be retrieved by me or my colleagues. Again, if you want, you can also save it as a local Parquet file. That also works straightforward. So here I save just the entire Treble10 dataset, which I enriched. So with all the added metadata, it's a Parquet file that's here. It's very memory efficient because there are no, let's say, the actual IR, so the actual audio is not in the data frame. It's just the metadata that we're working on. And that was kind of, you could say, it was by choice basically. So the operations and the filtering and everything is instant. And once you're happy with your setup or your distributions or the amount of IRs, then you fetch the impulse responses and consume them with a smartly made data loader, which I will get into a bit later. For the sake of the example, I'm also just saving the 2 living room datasets here that has slightly less IRs in them. If you have, you can say, a workflow where you go through hogging phase, a lot of teams do that, where we say that data lives in a private organization on hogging phase. Then you can also do that through the SDK. We integrated that as well. So here I'm pushing this lightweight data frame to the hub. It takes me 8 seconds basically, and then I can, if I want, I can load it back with this one line of code essentially. Now I have my IR collection again. Okay, we're now happy with our IR collection and we're ready to, you can say, use the underlying impulse responses to convolve with audio and create our audio scenes. So what I'm gonna do is I'm gonna instantiate the data loader with a certain options. I'm just gonna use the default options, which is lazy loading that loads one IR at a time. I can also use eco loading or lazy loading, but without cache. And then finally, I can also preload all my impulse responses if that's what I want, where I just download the whole data set or collection of IRs to my local disk basically, or my training machine that lives in the cloud. You can do both as long as it runs the SDK. So I'm gonna load my data loader here and set a work directory. This means that if you have already downloaded the IR, it goes very, very fast to load it again. And if not, it will then, you can say, spend a few seconds in downloading the IR. So that's what I'm doing here, basically, loading a spatial impulse response with the lazy data loading, and then we can plot it here to see, basically. We can also use this data loader to preload data. Again, if you want all the IRs on your machine, of course, we allow for that. The recommended loading is lazy, so that you just load as you consume IRs. It's a bit more efficient also for your disk space and so on, because we know a lot of users have issues with gigabytes or even terabytes of IR information being dumped on disks. This sort of data loading aspect is you could say meant to solve that, so you just load on demand essentially. But of course you can preload, and here I'm just preloading IRs from my collection where the source receiver distance is above 5. There's also examples here in this commented code where you just load all IRs, or you can say load the first 50 and so on. But yeah, this will just basically start downloading the IRs to my disk. Hopefully you found this detailed walkthrough useful for you. I mean, again, just to reiterate, the notebook that I showed you here will be available for you, both in the mail if you watch the webinar, but also on our documentation page on docs.treble.tech. Where you can view this, and we are very, very excited to hear your feedback on this feature. This is a completely new workflow in the SDK, and we are super happy to bring more, you could say, organized workflows, more efficient workflows, and better collaboration into this space. So happy to hear your feedback if you have any.